about. See, 423, 424. So if we did the presentation, then I'm telling, like, it would be like 2 years I would answer questions.
Yeah, it will be a full-time job, really, in addition to all your
right. Yeah, we're at 440. Yeah, this is a lot of people.
Yeah, when it hits 500, I will get started.
Okay, well, you might have to wait too long. It keeps going up every second.
Right. Okay, wonderful. Great to have you all here. Let's get started with the second day of the Global Quantum Program by WOMANIUM, Quantum Computing, Quantum Sensing, and Communication. We have a really excellent program for you today. We will start with a keynote, today's space race, Quantum Computing by Hurley, the CEO of Strangeworks. Then a keynote on quantum communication by Noel Goddard from Connect. And after that, we will go in depth to the parts where you also have exercises and quizzes, namely workshops by QWorld. The first one, Quantum Key Distribution, Classical Cryptography and Limitations by Asha Khalik, and Gibran Rashid, whom some of you have met last year, will be back with the Q-Nickel course, Quantum Computing and Programming, starting with basics of classical and quantum systems. It is really a great honor to have our first speaker here with us, Hurley, CEO and founder of Strangeworks. And at any good quantum computing conference, Hurley is invited. So he has been flying around the whole year, and it is really great to have you back with us today, even from your home base in the US.
Yeah. Yes, we're not talking from some other place in the world at 3 in the morning or whatever it was last time.
Last year you were in Japan.
Yeah, I believe I was.
Hurley is the CEO of Strangeworks. Previously, he founded Honest Dollar and Chaotic Moon Studios. He worked at Apple, IBM, Goldman Sachs. And like WOMANIUM, Hurley thinks quantum should be for all ages and also for all levels. So he authored Quantum Computing for Babies and also Quantum Computing for Dummies. And
yes,
last year, Hurley received many questions on LinkedIn from all of you, which was amazing, the most interactive audience ever. For that reason, we will move all the questions to the live session today. And yes, please share, Hurley, how you want to do it and
yes,
what this amazing session will look like.
So we had a great talk last year, and last year we talked a little bit about quantum, but we've done some surveys since then, and we understand that the audience, some of you already have quantum experience, some of you don't. There's plenty of opportunities to get that. Today, we wanted to change it up from last year and talk about the industry, where the industry is at, specifically things about representation in the industry, and kind of separate the myths from the reality, so to speak. Last year, I received maybe a couple hundred LinkedIn questions, and I responded to those over the course of about 6 months. And I felt really bad because some of the questions were time sensitive, like I'm trying to get a job at this place or I'm doing this thing. And so this year we wanted to change it up and make it a little bit, well, not a little bit, a lot more interactive, to where I will talk a little bit about some of the things I'm seeing in industry for like the next 5 to 10 minutes. They'll leave the bulk of the time for us to have an interactive conversation. So I believe, and Marlou, you can tell me, that there's a Discord channel for them to ask questions in, and then you will pick them, right? Is that correct on how we want to do the questions?
That is totally correct. So ask your questions
perfect.
on Discord in the channel Live Questions, and
yes.
Vardaan and I will share them with you.
And some of you are already asking questions, which is great. So we'll get to those. But look, we're in a very interesting time, and I'm going to talk about some subjects that are a little controversial, but I think they're really important. The first one is, is there a quantum winter, right? We see quantum computing becoming more and more popular in the media. Earlier this year in February, it was on the cover of Time magazine. It was a very exciting article, but you have to temper that with some reality and remember that a few years ago, quantum computing was also on the cover of Time magazine, saying many of the same things. And so several years pass, and what's the real difference? I don't think that we're going into a quantum winter, although I have predicted that for a while. I think that we're going to feel the economic pressures that are going on globally right now, that we're going to be in a situation where it'll be harder for startups to get funding. And we see a lot of startups pivoting right now. See a lot of companies that used to say we're quantum first are now saying they're AI first and maybe also quantum. And in some cases, they've dropped the quantum completely. I don't think this is representative of the industry in any way, shape, or form. I think this is representative of companies that may have some management challenges, they may have some other things going on, but I don't think you can take and extrapolate that and say, okay, well, we're in a quantum winter because there's not as much funding sources. The reality is they're almost all funding sources are drying up across all startups.
Can you
The
share a
only
bit
start,
more? Can you share a bit more?
yeah,
What is a quantum
yeah.
winter, and will we have a quantum summer again?
Yeah. So a quantum winter base, that's a great question. I should have defined that. Thank you, Marlou. The quantum winter basically being that we have a bunch of companies come up. You kind of saw people talk about this in around 2016. So in 2014 and 15, you had about 40 equity rounds into about 15 companies, and it looked like quantum was taking off. And then it kind of went down, and about 2021, it came back again very strong. These are natural ebbs and flows, especially in new markets that are coming into play. But a lot of people like to extrapolate that either the technology is not ready, so the funding sources dry up, or there's no customers, so the funding sources dry up. There's a bunch of reasons people push a quantum winter, as something. I think the reality is the economic times are tough everywhere. This should not be a newsflash to anybody. We've been pumping up economies globally since 2016. And I think that good companies win in every economy. And most importantly for everyone today, all great companies, a majority of them that I admire personally, were actually founded or started during times of economic downturn. So this is actually the best time, in my opinion, to get involved in a company or to be creating a company or to be pushing the boundaries of your company. So that's one thing. The quantum winter thing, it's up for debate, and everybody's waiting for quantum computing to have its chat GPT moment, right? AI has sucked a lot of the oxygen out of the room for quantum startups because investors, they've invested billions of dollars. There's been no giant quantum exit. There's been no company that's went public successfully. I mean, IonQ, you could argue has. They did get 600 million, I believe, when they did their SPAC in the public markets. Other companies, they got 100, they got 40, they got 10. And they're spending 70, 80, 100 million dollars in some cases a year. So I can understand where people would look at it and say, this is the beginning of the quantum winter because people are pivoting away from quantum because there's not as much funding sources, there's not as much excitement. I disagree. I think this is a natural culling of the space, that this is what happens in all markets. You have a new idea, it's very exciting. Thousands of people come in and start companies, dozens survive. I mean, this is not new from anything you hear about startups in any industry. So the first thing is everyone calm down. It's going to be fine. I don't think it's as, and I'm the person who's been saying, look out, the sky is falling. So if I tell you that, I feel like it's pretty sure thing. The second thing is we're still, my biggest topic you get asked about is misinformation around quantum computing. There is still so much misinformation, especially around the area of encryption. Quantum computers will break encryption. End of story. It's not a bad thing, okay? It's not a bad thing at all. I say that because throughout our history, from, Romans using paper wrapped around, scroll sticks to the Enigma machine and the world wars, encryption has always ended up being broken and something new is created. Using time and resource as a way to secure our data may, now that we're in the quantum realm, not be the best approach to securing things, and that's okay. But it's wrong ethically, to me, for companies to raise money from governments on this sphere. All the encryption will be broken, and everyone will have the password to your OnlyFans. Nobody cares. I don't care if I have the password to your OnlyFans or your Facebook. I do care that for the last 30, 40 years, spies around the world have stolen secrets on chemical weapons and nuclear weapons and all manner of other things that were encrypted with lesser technologies. Governments should be focused on those things because quantum computers will obviously break those a lot faster. But we have to start taking the encryption discussion off the table. What I love about WOMANIUM is that it's not just about quantum computing, So the sensing and the networking and all of these things are going to make stronger, more secure infrastructure for us. A quantum internet would be one of the biggest steps forward in security in the history of computing. And that's something that's being worked on actively around the world. So I'd really like to encourage everybody to take the conversation away from the fear and the uncertainty and the doubt and focus on the positive aspects of this technology. You know, we're not going to prevent a bad actor from breaking some encryption. Hopefully it's not too bad. What we can do is we can start talking about the positives and pushing us towards a quantum internet, you know, and the quantum sensing and the computing at a phase where it will actually help us. So, you know, the winter, you know, don't worry about that right now. It's going to be, you're going to see a lot of quantum companies go out of business in the next 12 to 16 months, in my opinion, or get acquired. There'll be, you know, consolidation of space. This is a good thing. This is okay. Right now, there's not enough talent, which is my third topic for today, out there, which is part of why I come and I talk to all of you. There's 621 people right now in this session, which is great. I would love to see all of you working in quantum. We need all of you working in quantum. And so, you know, the third topic, you know, the winter, don't worry about it. The encryption, we have to as a community. And I would encourage everybody in the WOMANIUM community to start downplaying it. Yes, it's going to break encryption. Okay, what do we do about that? Let's build the quantum internet so we have encrypted connections between two parties. Let's build new forms of post-quantum cryptography, but let's talk about this in a positive way. Because when you go to a government and you try to raise money with the fear and the uncertainty and doubt, you bring about the regulation, which is a topic I'll talk about in a moment. But, you know, the winter, the encryption, now you've got the workforce. The workforce is one of the biggest challenges. Every customer I talk to has 0 quantum people, right? They're software engineers, maybe they're material scientists, whatever. It's a completely new world for them. And when you see products used, if we're honest about the usage of these machines and software, you see a lot of people playing with them or starting, but they reach a brick wall. They reach a point they can't go past. Part of that is availability and cost of machines. Part of that is related to companies not having enough talent pool to pull in. Marlou and I were talking before with Lindsay before the session started about how the representation in this group out of the 630 people or so is probably about 45% or so, almost half women. That's amazing, right? We need to see all of that make it out into the market. We need to see people engaging in jobs, even at lower levels. Maybe you're not a quantum physicist. That's okay. You could be a computer engineer that knows a little bit about quantum, or a software engineer, or want to be a software engineer, and you could be the person that starts that at a company. So, you know, we get rid of the winter talk, we get rid of the encryption talk, we start focusing on the workforce and on the next topic, which is the regulation. When you take the fear and uncertainty and doubt and you go to governments, there's always somebody in the back of the room who is there to see how do they protect their country. And the regulation needs to, the last topic I'll talk about before we open the Q&A, which is nationalism. But the regulation is a big problem because right now we already have enough problems, enough challenges trying to go out and look at what, you know, these technologies will do, solving some of the fundamental quantum mechanics issues that we have with the noise control and the error correction, decoherence times. The last thing we need in quantum computing right now is regulation suppressing that even further, shutting down the innovation, stopping the collaboration amongst companies or amongst countries. And we're starting to see that more and more. That's driven by 2 factors to me. Number one is going to be, you know, this fear and uncertainty and doubt of, you know, the scary technology. Look out, some country's going to be better than you. It's not, doesn't lead to a collaborative process. And the second is the regulation. When you have those 2 combined, you can see a very suppressive effect on a market. And so I worry about the years of drumming up the fear and uncertainty and doubt now leading to the regulation, as regulators look at AI and quantum as 2 technologies that go together. You know, they're absolutely in a marriage. Strangeworks, we founded the company to focus on the convergence of the 2 technologies. I believe that quantum computers are going to need a lot of help from AI to solve some of the fundamental issues we have with scaling them and making the data sources, you know, we have no quantum memory, we have no, you know, there's so many things we're missing. And those are all opportunities for every one of you. And that's why I get excited with the workforce conversation. But the regulations, that leads into the nationalism I mentioned a moment ago. And the nationalism is a big issue. Right now, countries are focused on their quantum computing companies in their countries. We're seeing collaboration actually kind of not consolidate, but get compressed into fewer and fewer groups that are truly openly collaborating. This reminds me of why I started Strangeworks. In 2016, I tried to get Goldman to do quantum. At that point, it was a little early for them, no worries. In 2017, I got a lot of the leading hardware companies together at the offices of IBM in the summer of 2017 to work together. And they didn't want to work together. They all thought there'd be one vertically integrated stack, trillions of dollars made. They're the biggest company on the planet. And that meeting was to start something with the Linux Foundation called the Global Quantum Initiative. Well, when nobody wanted to participate, we basically took the Global Quantum Initiative and made it a company called Strangeworks. This is the beautiful thing about being an entrepreneur, is you can do that. But it's really important that we start looking at the effects of nationalism on this. You see this in France, you see it in the US, you see it in Finland, you see it in Germany, you see it in everywhere. We now have countries that we're working with that 2 years ago, we would have set up an operation and worked with them, that now I'm not a citizen of that country. Already, that's a big negative. Now I wasn't born in that country, that's a big negative. This stifles the innovation. Look, there is no country on earth that has a massive lead in quantum, hands down, end of story. And we need to work together to be able to do all of the things that we're all dreaming of doing. So with that, I've talked a little longer than I thought because I got a little preachy, but I would like to start taking the questions from the audience. But just remember, and AI questions are fair too, because, when we talk about that convergence, remember that, we need the AI to solve some of those quantum problems. Well, also, AI already knows about quantum computers. So it's already writing algorithms and starting to look at things that won't run on classical infrastructure anyway. So these two technologies are symbiotic. And I believe that you need them both in order to do any of this work that we're talking about doing. And with that, Marlou, perhaps we could jump into the questions, because I rambled a little long there for us, and I apologize.
That's amazing. And there are many, many questions indeed. I would love to, for you, Vardaan, to help me relay them to Hurley. The first one about the quantum winter, and you mentioned AI. Is the cycle that we go through for quantum comparable to what we had for AI previously?
I think it is. I think it is. I think they parallel each other a lot. I have been aware of AI since about high school, about 1984, 85, when a guy named Doug Linnett here in Austin, who's a very famous artificial intelligence figure, created a project called Psych, which is with CYC, which you can go Google, which is going to be a big inference engine. Doug is still working on that. I mean, it's been a long time. And even 5 years ago, people would have said, well, where's this going? Because what happens is, look, it's natural for entrepreneurs to exaggerate, to elaborate. It's not our style here, but it's totally understandable. No harm, no foul. When you do that, you see these peaks where I say it's the greatest thing in the world. AI, let's talk about 1988, 89. AI is coming. It's going to be here. It's here. People invest. There's no revenues generated by it. There's no profitable companies. They pull back. A few years later, I say, well, there's been a new advancement, and this is the, and quantum computing has went through that for many years now. So there's a direct parallel, and I think we could learn from the several AI winters that have happened, how we could do it. And I think what we would learn in that case is very simply that you can't overhype the market. That is the most dangerous thing. You must have validated, provable, demonstrable points on the technological wins. And 3, you have to have a strong community that has the same message. If I go out and I say hope and peace and joy, quantum network security will be great, and you go out and 4 others talk about how it's going to be negative, my message doesn't get heard because everybody says, well, these other people say the opposite, right? We need to have one voice as a community. We need to be together. Everyone in quantum should have the same talking points, the same positioning. And the reason I say that is not only will that be valuable, that will be valuable to us developing the technology, because that will force us to have conversations about perhaps this technology is better at something, or this approach is better at something else. Very, very, very important. Marlou?
And one of the bottlenecks there is the hardware. How do you see the gap between
100%.
hardware of quantum computing and software? How does this affect investors' opinions, is what Paulina asks.
Well, Paulina, I can talk about that one from personal experience. When we started Strangeworks, no one wanted to fund us because we were a software company. And they said, how could you possibly build software? The hardware doesn't exist. So that is 100% something that has happened for the last 5 years that I'm aware of and continues to happen. Still today, 80, 90% of the funding goes to hardware companies. And hardware is, the first word is hard. It's hard. It totally makes sense. But the value for quantum computing won't come from the hardware. It will come from the algorithms and applications that run on the hardware, right? So, I mean, you just think about the information revolution, it was the second revolution after the Industrial Revolution, and now we're doing a quantum revolution. So think of the information revolution. So where did the value ascribe? Did it ascribe to, Intel's processor or Microsoft's operating system or all of the applications? Look at a company like Apple. The hardware is phenomenal. The research they're doing is absolutely amazing. And they've come up with a really good plan. They charge really high prices and it's almost an affinity purchase. But where is all of the value? All of the value is in the applications, right? In the software. And that doesn't mean there won't be value in quantum hardware. I'm not trying to say that. I think they're they're two things that go together, but lacking investment in the software hurts the community. It hurts our progress. And the reason it does that is because as a hardware developer, a company can't get feedback from the people that will actually be developing the applications. So there's a disconnect, which means we don't have an OTA feedback loop where we can observe and detect and take actions on things. We have a situation in where I'm developing my hardware in a vacuum with what I think the software is. But the one thing I can tell you, having done this startup stuff for almost 30 years now, is startups rarely end up being what they rarely end up being what they started out to be. And without having a complete ecosystem, products fail and they suffer, right? And then they don't land in the market. Flickr, as an example, was a game that failed in the market, not a photo website. And you could go through hundreds of examples of that. And I think you'll see examples of that in quantum too. All right, Marlou, I'm going to try to start being a little succinct to get to your questions because now there's 657 people.
Yes, great. And Vardaan has also shortlisted some questions.
Yeah, sure. So first, hi, Hurley. Someone from India asked that, does media hurt quantum, especially about the hype? And how should these quantum enthusiasts that we have in our program, how should they approach this hype and separate that from the reality around it?
That is amazing. Yes, media affects us greatly. In fact, I kept a copy of the Time magazine handy for today. This exact cover with this almost exact story came out 7-8 years prior, right? It was a black cover and it said the CIA and everyone is working with a new computer that's going to change the world in the next year or two or whatever. The media is a big part of the problem. I'm not anti-media. I love them. But I'll give you a recent example. I did an interview with someone. I've had this happen 3 times this year already, where I tried desperately to explain it's not everything between 1 and 0. It's a probability of a 1 or a 0. And it's this and that. And still the stories come out and it's wrong. And it hurts the media credibility and it hurts my credibility because people don't know whether I know what I'm talking about or not. So they read it and they say, oh, I tried to explain a Hadmar. So the media story came out, it said, oh, you can rotate it on the X, Y, Z, or H axis, right? It was like, okay, close but no cigar. So media has a very important role to play, but more importantly, that's on us. We are the community spreading the fear and uncertainty and doubt. We are the ones who are like, it's really hard. We'd like to explain it to you, but you might not get it. We have to take the time as a community to educate the media. I'm actually looking on my personal website at building out a media resource right now. So I'll be launching a new WHURLEY.com in a couple of months. And part of what it'll have is all giant FAQ built up over the last 5 years of this is real, this is wrong, this is right, this is wrong, this is real, this is true, this is false. And so I think the media plays a really big role. They drive the interest, but media has suffered so much in the last decade. Media is now about the clickbaits. You read these titles and the title never goes with the article. The title is all encryption's going to end. And it's like, maybe in the next 10 years, right? Like there's a disconnect, but nobody reads the whole article. They read the title and the abstract, and maybe they skim for a quote or two. And in this modern world, there's another aspect to that media that affects it, which is the social media, which is you could put out a false thing about quantum today, and if you did it right, have 100 million people see it by tomorrow, right? And then everybody's like, well, that's what I read. That must be true. It came from a semi-credible source, or even be misquoted. So this is a big issue. I think we have to work as a community to educate the media on the realities of it. And I think we have to be honest. It's okay to say we do not have a quantum industry today, because we don't, right? This is not an industry. It's like the homebrew compute club in the 80s. There's a bunch of us, thousands of us around the world with this awesome tech, and we're playing around with it. And we're trying to start companies and do stuff. We haven't broke that into an industry yet. Industries need finance. One of the biggest areas of the media I'll be critical, and I'll go to the next question shortly. I know I'm getting very preachy, but with the media, analyst, I read every day I get an email that says, we'd like to sell you this research report. Here's a sample about how quantum's going to be worth 23 billion by the year 2025 or whatever. That is not true. It is huge, it is big, you should all be involved in it, but we should be realistic about where it's at. If you look at the usage of the machines alone, you know how many people are actually doing any work on these, right? And it's not a lot. The good news is, when we started 5 years ago, there were maybe 200 people worldwide that mattered in quantum. Now there's thousands. When we go to a conference, there were 20, 30 people. Now there's hundreds. There's 659 people here, right? So this is changing. This is ever changing, and this is really, really important that we don't criticize the media as much as we help them, right? We can't just be like, oh, a stupid reporter doesn't understand quantum mechanics. Yeah, no kidding. I mean, why would you expect them to, right? It's our job to explain it to them. Anyway, did you have another question there?
And what you tell, this is exactly the reason that we initiated the Global Quantum Project. Beyond all the modules everyone will do in this program, there is the aim to teach at least 5 more people, or to put media online where you share your quantum insights. Because you say, Hurley, people can put a false statement and 100 million people see it. Now everyone here, almost 700 people, will put true statements and 100 million people will see it.
Well, it starts like that, right? We work together, and but one of the things I'm going to call for, I'm writing a white paper on, is for all of us to agree on certain points. A great example of that is standards. They suffer the same problem. 5-6 years ago, I started a standards project with the IEEE. I can't get people to agree on nomenclature. The next standard is on benchmarking. So how am I going to get them to agree on the benchmarking? Guess what? I'll predict it. All of their machines are better than all other machines. Yay! That doesn't help us as a community, right? It doesn't push us forward. It doesn't do anything to build community, to build cohesiveness, to build an industry on top of. Those are things that we need beforehand.
Right. Yeah, absolutely. The next question I would take on is from Saurabh, and I think this question might be common from all the students and all the professionals who are looking to jump into the quantum industry. And as you might already predicted, what are the best skills to enter into the quantum industry, and how important are academic qualifications, maybe PhDs, to get into the industry?
So this is such a loaded question. Okay, so look, we hire at Strangeworks for 3 things. Number 1, we hire for culture. More than anything, whether it be a startup or a university program, the people you're bringing in need to be able to fit with the people you're working. That doesn't mean it's the same people. That doesn't mean it's not diverse. It just means that you know what you want your company, your project to be. The second thing is we hire for competence. And this will kind of touch on the education thing, but I'm going to go into more depth on it in a second. Competence is not experience. I don't care that you have a degree from the greatest quantum university or you've been doing it for 20 years. You could still suck at it, right? Just nobody told you for 20 years. So I care about, that. And the last one, which is the most important and probably the biggest skill I believe is required in this industry today, is creativity. It is super, super hard. But if you want to learn about creativity, and I don't know him, I don't get anything, but a book I just bought for my entire team is Rick Rubin's. It's called The Creative Act, A Way of Being. If you don't know who Rick Rubin is, Rick Rubin was in a dormitory in college when he discovered what was initially the entire rap industry. He is the one who created Public Enemy. He created the NWA, like hundreds of things. He's touched every bit of music that you've listened to. He has made untold sums of money. He has a studio with white walls. No, he takes his Grammys and his gold records. He sends them to his parents' house. He doesn't even know where they're at. He is focused purely on the creative act, and he's a great inspiration for the quantum community. And I'll tell you why. Because we need to question everything. And to question everything, we have to have a very creative and critical thought process. It can't just be, I learned this at university, this is how it is to be. It can't be me saying, I've done this for 30 years. This is the only way it would work. This is a brand new industry. It's very important now. We don't have enough PhDs in the quantum information sciences, period, full stop. When we started, there were 4 or 5 master's programs. Now there's almost 50. That's still, if they all cranked out as many students as they could, it would not fill the gap in the industry. That's where we need to start using other skill sets like software engineering to develop things that augment that, so that a person, instead of being a 1x physicist, can be a 10x or 100x and do more, right? That's where we need abstraction layers to lower the barriers of entry. My focus has been for the last 5 years, lowering the educational barrier requirements, lowering the cost requirements, and lowering the availability, right? Making it where it's very available, it's very cheap, and you don't have to have a lot of skills to get started. You can build those skills on the journey. I think what you'll see in quantum computing will be akin to software development. In the early days of my career, everyone was an electrical engineer from a big university, and they were all the software developers. Now it's like, my 7-year-old can use OpenAI, and he's also a software engineer. So I think that you're going to see, and we need the same kind of approach in quantum. And there is a cultural difference here between the universities and the startups and the people that we hope to sell these products to. And we really need to address that and bring these people together. I know it sounds very kumbaya. I mean, I keep preaching, everything I'm saying today is about, but we're entering the most critical time in quantum computing. It is ours as a community to mess up and delay it another 10 years, or to make next year the greatest year quantum has ever seen, right? But to do that, we have to be creative, we have to collaborate, and we have to be supportive of each other. People ask me about competing companies all the time. I say, I talk to them all the time. Why would I not? I mean, I think I said this last time, so it's kind of, and I need a new analogy, it's getting old, but I compare the state of the industry to a restaurant. And we're all in the kitchen, and Marlou has flour all over her face, and I've got berries all over me, and Vardaan's putting out a fire on the stove, and the sprinklers are raining down, but we're all going to own that entire pie. We haven't even baked the pie yet. We haven't even collected all of the ingredients for the pie yet. We have so much work to do, and it's so exciting. It's such incredible work, but it requires us to do a lot together. When it comes to universities, we need governments to invest more in university programs to educate in the quantum information sciences. We also need to drive those programs down into high schools even, and lower, so that we start teaching quantum as a new thing, as the way things are going to work in the future world for these children. Now, I did an interview with Dad Saves America, where he talked about how do you prepare your children for that future. And it's switching from the purpose to the passion. And with quantum, I want to see people start being more passionate about it. It is going to be the greatest technological revolution in computing science in the history of it, period. Like, without a doubt. Now, will something else come along in the future? I hope so. I hope we keep to advance. But right now, this is the biggest opportunity you could possibly be taking part of. Don't let not having a degree keep you from getting into it. Don't be afraid to go invest, 4 or 6 years and get a degree, right? We need all of these things. We need all of these people. So it's not an either or, it's an and it's how do they collaborate and how do they work together?
Yeah, fully agreed. And especially starting at high school level or even earlier, even in our WOMANIUM team, we have 4 high school students. And some of the great team members, it doesn't matter if you're postdoc or work in industry or PhD, having that passion for quantum, entering the field right now and contribute. Regarding the timelines, I would like to combine 2 questions.
Sure.
We currently have many machine learning engineers. It became almost standard on teams. Now there is a question, how long will it take until one will have a standard quantum engineer on the team? And can we already do something now? How useful is this NISQ era?
Okay, great. Okay, so I'm going to take the NISC era first, and then I'll go to the quantum. The machines are useful. I have companies all over the world paying me money to use the machines. That's good. That's step one. When they come back and they pay me more money to continue using them because they got a return on that investment, they're useful. You know, my argument for this is I talk to a lot of people in the governments around the world, and usually these people are older. And I say, well, what was your first computer? And they say, oh, it was a TI-99 4A or a Selectron this or whatever. I say, well, the iPhone is so much more powerful. Why didn't you just wait for the iPhone before you started doing computing? And they laugh. But that's what people are doing right now. They're saying, we'll wait till quantum's perfect, and then we'll take a look and we'll use it. And it's like, that's such a horrible attitude. The machines are very useful, and they're very useful on a number of levels. They're useful to customers because it's such a dramatic disembarkment from the path that they're on, that they can start educating themselves in their workforce internally. It's useful to scientists because they can start thinking of these new algorithms. It's useful to companies like mine to do all the benchmarking, the testing, and find out where is the industry actually at. So yeah, it's super useful in the NISC era, and I don't think we'll be in that era that long. And Jay Gambetta and the team at IBM, who, full disclosure, IBM is one of the investors in Strangeworks, even though I don't know that we're I don't know how I don't know that the quantum, I don't know. I think the quantum team loves us, I hope. But you know, when you look at what, you know, he said in that recent paper, there's a bunch of work you can do with these right now. I also don't think we're going to be in the NISC era as long as people think. I had the benefit of seeing a lot of hardware that is unreleased, and I'm starting to see some really amazing progress in some areas. One of my most fascinating ones is in the area of using helium electrons to build these machines. There's a lot of stuff happening. And as companies start to adopt AI, they're able to consume more research faster. They're able to do different development schemas. So things are moving along in that. And I got off on the NIST guy. Sorry, Marlou, I forgot the first part of the question. If you could repeat that. The NIST thing bugs me, obviously.
Right, totally. Will we have a standard quantum engineers on teams? And when will that happen?
Yeah, I think it will happen. I think to compare that appropriately, you want to compare it to data science. So it won't really look like AI stuff, and people often conflate those two. If you look at what happened with data science started as a very small field, very specific in very certain areas like bioinformatics and things like that. As data became, you know, more abundant, then it obviously naturally grew. The data for us is the access to these quantum technologies. As we get more and more people access, it will drive more and more usage. It'll drive a requirement where I need someone on my team or someone, you know, close to me that has the knowledge. It's my quantum subject matter expert, right? So, you know, I think you'll see it. As far as when will you see it, I'm seeing it already, but I'm not seeing it in the way you'd think. I see Fortune 500 companies starting to say, we have this person who's usually not a quantum person. They don't have a information science degree in quantum information science. They don't, and this is going to be our lead. And their job is to go out and explore and study everything. So I'm already seeing dedicated people on teams across my customers and across the industry. I think they would have more quantum educated people if we were producing more of them. I mean, you have to think about how long it takes. And this is something we don't talk about. You can't just take a developer and be like, okay, write quantum software, right? It doesn't work that way. You can't just say, now I'm quantum knowledgeable. But unfortunately, it's a very hard science, and it does take a lot of time, frankly.
Yeah, the next question I would take is from Pablo. He has a very genuine question. He asks that, will all industries, and emphasis on all industries, will be affected or benefited by quantum? Or are there some industries which should maybe wait for the right time to adopt this technology?
That's a great question. Yeah, I think all industries will be affected. And the reason I think about that is that, you know, think about the internet, right? I see quantum computing as a technology similar to the internet. In other words, meaning that it will touch all aspects. Even if I don't use quantum technology directly, okay, I will end up benefiting from it. So the classic example for you. Let's take a look at, I don't know, autocorrect on text messaging, right? So what is autocorrect? All right, well, it's a technology that keeps me from saying stupid stuff in a text message to my wife. Nope, still happens all the time. Quantum computers and AI, one of the things they'll do is they'll be able to make better predictive analysis of text. So I won't know I'm using a quantum computer, but I'll benefit from it. So take that, to its logical conclusion. Well, just like the internet, I may not realize how much the internet plays a role in every message that comes across, everything. Quantum will be this underpinning technology for a lot of industries. Now, other industries will use it much more in a dependence fashion, drug research, material sciences, things like that. But yeah, it'll affect all industries. I mean, just think about it from the text message example. Think about it from search. Why is Google investing so much? Well, because we're getting more and more data, and it's harder and harder to search, and we don't get the right answers. My mom will use quantum computing without knowing it, that are using Grover's search algorithm to find the things she's looking for. So I think it will be used by everyone. The question is, what's their awareness of its role in their usage? And then where does it scale in these certain verticals?
A question related to, will everyone use it? A bit visionary. Do you think that quantum mobile phones will be a real thing connected by the quantum internet?
I mean, look, I would hope so. I would think probably not in my lifetime, but I would love to see that. I mean, it would be amazing. The thing you have to think about is, how would you control those electrons in a package this size that would have the kind of battery power you would need, et cetera, et cetera, et cetera. It's a ways off, but you can make any prediction about the effects of quantum that you want right now today, and eventually they will potentially come true, right? I mean, we don't know. The problem that's hurting our industry is not what we don't know. It's all the things we think we know 100% certain for fact. This is what's hurting us as an industry, right? The unknown. Could it be in a phone? Could it this? Could it that? This is that creativity I talk about. Why not get a group of people on this call to go and collaborate and come up with all the reasons it couldn't, and then get that to another group of people that are just like, I'm going to prove you wrong just because, like, we need this collaboration. We need this stuff, but everything is possible. I mean, this is the greatest time to be alive in the history of our species from a standpoint of what we know technically, what we're about to achieve, and where that could take us, right? It's just amazing.
I feel we could talk for at least 2 more hours, but I will ask a last question, Vardaan, a last one, and then your last advice to everyone.
As long as it's not the Black Mirror question. I'm just kidding. I'm teasing.
Yes. What is your advice for the future quantum entrepreneurs among this group?
Okay. My advice is very simple. There's no future quantum entrepreneurs. Go be a quantum entrepreneur today. What are you waiting on? Get off your ass. Like, there's no, like, what are you going to wait for somebody else to start a company? You start, go do this. You could start consulting. You could start researching. You could start advice. There's a million opportunities. One area, if you're just doing marketing stuff, would be, how do you get people to market the technology ethically and responsibly, right? There's so many opportunities, and yes, there's not a million jobs in quantum right now, but the way we'll get to a million jobs in quantum is the people on this call starting projects, starting companies, doing stuff where they need resources, building that community. I keep harping on the community thing today, but it's really, really upsetting. It's that, we're not spending enough time, evangelizing together. We're not spending enough time working on what are these future ideas, what are these future possibilities together. We're all off in our own world with our own kind of opportunities, and we feel that if we share that data with anybody, they could do it because the money's getting dry, so maybe they'll steal it, or maybe this. Look, people are going to steal your ideas anyway. That you would be so lucky that you would have an idea good enough that someone would want to steal it, right? Imitation is literally the highest form of flattery. So it's like, there's no future quantum entrepreneurs. There are quantum entrepreneurs today. If you want to do it, go do it. Stop talking about it. This is part of what's frustrated me for the last 2 or 3 years. I've met hundreds of people. They're like, one day I'm going to do this startup in quantum, or one day. The day is today. The time is now. And as I said at the beginning, and I'll end with this, most of the companies I admire that are very, very successful, these companies, okay, they were all started during times of economic downturn. All right, period. So this is a great great time to be able to get out there, start something. And by the way, oh, you're afraid of failure? Most startups fail. You'll probably fail. That's not a bad thing. You'll learn a lot from it. You'll refactor it. You'll do it again. I mean, this is, you know, you need that drive. You need that presence to push these things forward, especially when we're talking about technologies that are as expansive and as world-changing as quantum computing. And there, I will shut up because I know we're over time, and I'm now making you 2 minutes late, Marla. I'm sorry.
Well, I just received 130 new questions, so.
Well, email them. Okay, so here's it. So give me a list of all the participants. Everybody can just add WHURLEY on LinkedIn if they want or whatever.
Great.
Send the questions to Discord. I will take all those questions and I will roll them into the new website and let Marlou know when it's out, and I'll make them all part of an FAQ where I can. And then you'll have those answers and answers to a bunch of others as well.
And we have everyone contribute to creating FAQs with the best answers that can contribute to the projects. Vardaan, I know you have also selected one last question.
So Wally, what would you maybe predict or on the optimistic side desire to be possible in the next few years in the quantum computing domain?
I think we'll have a defining moment in quantum before the end of next year. I've said, I think it could still happen this year. I'm a little worried, but for 5 years, I've predicted that 2023 would look like 1963. 1963, Jack Kilby invents the integrated circuit. Before that, you bought transistors one at a time. That was about 1959. Sorry, about 63, it had been integrated. So now think of, we've taken a little longer, but now quantum's kind of getting out there integrated. I think will take off much faster. That's one. Number two, there's going to be a lot of consolidation in the market. There's going to be a lot of our quantum friends and companies and partners that just don't exist. They're going to have trouble raising money. They're going to have trouble keeping talent, whatever the case may be. And that will lead to a talent war, right? There'll be companies that amass large sums of capital that will try to buy everybody. We already see this happening. This is happening today. So those are two things. As far as the technology goes, I think, you know, when will it break encryption? I think it'll do that much sooner than anybody else thinks, before the end of the decade for sure. And then my last prediction would be that we will have a very big dip in the industry for, you know, funding, for talent, all of these things. And I think we're starting that decline. That'll be very short-lived, and then it will rocket up because I think it'll happen in tandem with some of these other things that I'm talking about.
Hurley, thank you so much for this amazing session. We'd love to have you back next year, all subsequent years, and many questions and FAQs are coming your way.
I'll try to answer all of the questions by next year.
Promised. Thanks.
All right. Thank you so much for having me. Thank you, everyone.
And then we're moving in another very exciting session from quantum computing to quantum communication.